Hello everyone, my name is Satyakam Pratap Singh and this is the ninth tutorial session of the DC Microgrid and Control System. Whose instructor is Professor Avik Bhattacharya sir, and I am the PhD research scholar at Department of Energy Science Engineering IIT Bombay. So this is the last tutorial session of this whole course. So after that you have exam schedule. So this can be helpful for solving the question related to that, and some of the fundamentals should be cleared in this tutorial session. So so this is the first question which I have put it regarding the basic, that is the related to the basic definition of microgrid. Okay. So I have put it the few statements, later five statements are there. Just you have to tell me that which statements are true and which statements are false. I'm giving you a few minutes to solve this question. Just let me know if you got the answer. Right? You can write in the chat box or you can just open your mic and ask me. Last 1 minute to solve this question. After that, I will give the solution for this. Okay, let me give the solution for this question. Just read out the statement what is telling. Uh, if you read the first statement, what is telling that the mac microgrids are decentralized energy system that can operate independently or in conjunction with the main power grid. That is true because it's a kind of decentralized energy system which can be operated independently or in the conjunction with the main power grid. Second statement telling microgrid typically relies only on the renewable energy sources such as solar and wind for their power generation. That is false. It is not only related to the solar and the wind. There are other resources are also there when there uh, if the solar is not available, what you can do in that situation, and the wind is also not available, so you need the backup in that source. Energy storage systems are there, and also you have this diesel generator associated with that. The statement is telling primary purpose of the microgrid is to provide a reliable and a stable power supply during the grid outage. That is true. Microgrid are mainly leading the first like statement what is telling the microgrid are mainly used in the urban areas and have limited applicability in the rural or the remote location. That is false. Because this is mainly related for the remote location where the main power supply you cannot be easily available. In that scenario, we can just place a microgrid at that point of place so that you can get the reliable power supply. And the next statement is telling advanced control system are the essential for the optimization of the performance of the this microgrids and the balancing the supply and demand of the electricity. That is true. Okay. So this is the first question. Second question is also related to the few statements regarding the microgrid because it is also a basic topic for that. So here also I have put it the six statements. Just you have to tell me that which statements are true and which statements are false. Okay. I'm giving you a few minutes to solve this question. Just let me know if you have any doubt. Okay, let me give the solution for this question as well. First statement, what is telling that microgrid operates independently of the main utility grid and do not require any connection to its power supply. That is false. Second statement is telling microgrids are primarily designed for the urban areas and cannot effectively serve as a rural or the remote location. That is also false. Microgrid typically relies only on the renewable energy sources such as solar wind for their power generation. That is also false. Microgrids are incapable of islanding themselves during the emergency or the grid failure without manual intervention. That is false because we have the manual intervention as well, but you have this automatic detection of this islanding situations as well. Microgrid have no significant impact on reducing the greenhouse gas emissions since they primarily rely on the localized power generation. That is false. And the next statement, what is telling microgrids are cost prohibitive and not economically viable for the widespread adoption in the most area. That is false. It's a cheaper as compared to when you taking the supply from the main grid. Sometimes because you have the locally generated, locally energy generating sources. So that is the energy generating sources that is more reliable in as compared to the when you are taking the power from the grid. Okay. So here the question is related to the management of the microgrid, how it is going to be managed during the operation of their microgrid. So here I have put in the five statements. Just you have to tell me that which statements are true and which statements are false. I'm giving you a few minutes to solve this question. Okay, let me give the solution for this question. Uh, See the first statement, what is telling that the control strategy and the power management schemes are critical aspects of operating a hybrid AC-DC microgrid and essential for providing the operation in the both grid connected mode and the standalone mode. That is true because the control strategy and the power management scheme, they are the very critical state because you need to check whether the power is actually coming from the which generating source at that particular point of time so that you can control and you basically you can also there are features that you can predict this what could be the generation at the next moment. Okay, so if you can see the second statement, what is telling in microgrids, the management is divided into a power management and the energy management based on the control talks and the time scale. That is true because there are two kinds of manager at particular moment, that is a power control, and in the overall span of a few hours or few minutes, that is actually the energy management. How you can see the power multiplied by T and integrating over a time period from some T1 to T2, that is actually the energy. Okay. So if you see the third statement, what is saying, the short-term power management strategies, they are aimed to influence the instantaneous operating conditions that have voltage, current, power, and frequency in the microgrid. That is true. Okay, and the next statement, what is telling, the power management strategies include the voltage and frequency regulations as well as the real-time power dispatching among the different power sources in the microgrid. Okay, that is true. And the next statement is telling energy management algorithm focus on focus on this word and the total power production to meet the demand in the optimal way. Considering the factors such as the fuel cost, capital cost, maintenance cost, and emission profiles in the lifetime. That is true. So in this question, all the statements are actually true. Here is the next statement. It is a kind of matching question is there. So here the left hand side certain statement is given and that is related to the one word on the right hand side. So just you have to tell me that which statement is correctly matched to the right side words which is given. Okay. I'm giving you a few minutes to solve this question. Okay, let me give the solution for this question. Just yeah, I hope you have read it out the questions. Okay, so here the statements what is telling that the first statement, if you can see, the ability of the microgrid to disconnect from the main utility grid and operate autonomously during the emergency or the grid failure. That is actually related to the islanded operation. That is one thing. Second statement is telling techniques used to manage and optimize the distribution of the power within a microgrid and ensure efficient utilization and the stability. That is actually the energy resilience. Okay. Third statement is telling the integration of the various small scale power generating sources such as the solar panels, wind turbines, and energy storage within the microgrid. Actually, that is related to the load balancing. Okay. And the mechanism of connecting a microgrid with the main utility grid to exchange the power and the support grid stability, that is the grid interconnection, and technologies and algorithms employed to monitor, manage, and control the operations of a microgrid, including power generation, storage, and distribution, that is the DERs. Okay, and the capacity of a microgrid to maintain continuous power supply even in the face of the disruptions or disturbances enhances the reliability and the sustainability, that is related to the control systems. Okay, so this is the overall picture of this question. So moving ahead to the next question, that is important. I am giving you few minutes to solve this question. That is only 2 minutes are sufficient for this. Okay. Left side, this is given the type of the microgrid. Right side column is the capacity in the megawatt. Just you have to tell me the which classification is related to the which capacity. Okay. Okay, let me give the solution for this question. That is related to the types of microgrid, and the right side is the what is the capacity related to that. So the first type of microgrid is the simple microgrid. Simple microgrid is actually the capacity of the less than 2 megawatt. It can be seen from this name itself, that is simple microgrid, which is lower than the all the above which is given shown here. And the corporate microgrid, it is of the 2 to 5 megawatt. It is a option. Feeder area microgrid, it's a 5 to 20 megawatt. Okay, and the next, if you can see, is the substation area microgrid. It's of greater than 20 megawatt. Okay, independent microgrid, it depend upon the loads on an islanded operation, a mountainous area or a vessel where it is being set up. Okay, so here the classification: simple microgrid less than 2 megawatt, corporate microgrid 2 to 5 megawatt, feeder area microgrids 5 to 20 megawatt, substation area microgrids greater than 20, independent microgrid depend upon the loads on an island. Okay. So here the one question related to the typical architecture of the DC microgrid. There are 5 statements are there. Just you have to tell me that which statement are true and which statements are false. I'm giving a few minutes to solve this question. Let me give the solution for this question. This question is related to this one of the topic related to this DC microgrid. So if you can see the first statement, what is telling a typical architecture of the DC microgrid, it includes the multiple DERs and such as the solar panels and the wind turbine. That is true. Second option, what is telling that in typical DC microgrid architecture, energy storage system like batteries are often integrated to store the surface energy for the retail use. That is true. When the generation is greater than the demand, you always store the extra. That is generation minus PD is actually being stored in the PESS. Okay, energy storage. So that can be utilized when the generation is lower than the demand. Okay, and the third statement is telling power converters are not necessary in the architecture of a DC microgrid as all components operate on the direct current. That is false, because all current don't operate in the DC, but actually you need the power electronic interfaces to connect with them, connect with the utility grid and also in between the systems as well. Suppose your fuel cell, your DC bus voltage level is different than the what you have at as voltage level at the energy storage system. So in between you need the DC converter. So power electronic converters are the backbone of this DC microgrid or the AC microgrid. Okay. Fourth statement is telling the DC microgrid commonly incorporate a central controller to manage the power flow, voltage fluctuation, and the fault detection. That is true. You need a central controller which manage all the power which is going from the one into the another in, and also the regulate the voltage depending upon the what kind of power flow and the reactive power flow is happening. In the fault detection case, it's also detect the fault safely and also disconnect the microgrid from the utility grid. In the first statement is telling in a typical DC microgrid setup, loads are directly connected to the DC bus, minimizing the need of complex AC/DC conversion equipment. That is true. Okay, so this is a correct answer of this question. Next question is related to the purpose of the storage devices. Okay, so I have put in the few statements. Six statements are there. Just you have to tell me that which statements are correctly depicting the need of the storage devices. Okay, in the all the six statements. Just let me know which statements are true, which statements are false. Last 1 minute to solve this question. Okay, let me give the solution for this question. So this question is related to the advantages of the using this storage device into the system. Okay, so if you read the first statement, what is telling, the increasing the share of variable RE generating sources, that is true. Second statement telling to address the intermittency of the VRE, that is true. Third statement telling enable electrification and the decarbonization of the end use sector, that is also true. Next statement telling the access VRE can be stored and used in the consistent and controlled manner, that is also true. Potential solution to increase the system flexibility, that is also true. Next statement telling unique ability to quickly absorb, hold and then re-inject electricity, that is also true. Next statement telling can be deployed and scaled close to the location of the need, that is also true. So all the statements are actually true related to the storage devices, which actually handles the increases the share of the variable in renewable energy resources, is also capable of addressing the intermittencies, and third, it is also helping in the electrification decarbonization. In excess of the VRE can be stored and it will be given when the generation is lower than the expected, and it also have the solution to increasing the flexibility, quickly absorb, hold and reinject electricity. Is just talking about the charging and discharging rates, and it is also deployed in the scaled close to the location of the need. Okay, so this is the correct answer of this question. Next statement is related to question related to the demand side management strategy. There are different types of demand side management strategies, so I have given the six types here, and the right side you have to match with the correct. Suppose the A is matches to the first, yes, you have to write that ki A is matches to the first, like that. Okay. Okay, let me give the solution for this question. That is actually related to this type of the demand side management. So if you can see the images which is there. So first image is related to this. This is the peak which go in the particular duration of the whole of the day. So if you reduce that, that is a kind of the peak clipping. Okay, you are reducing, you are clipping just the peak which was there initially. Okay, so B, if you can see, B is actually for the valley filling. Means this is the valley which is there, and this is also the valley, one of the valley. So you are just filling up this valley. Okay, so this is the second is the valley filling. Third, if you can see, it's a load shifting. Okay, because you are shifting the load from here to here, here to here. So this is simply a load shifting. Next, if you can see, it's a conservation. Means you are conserving the overall energy what was there. So this is the currently the energy state, and this was the initial what was there. So this is a kind of energy conserving. Next is the flexible load. Means you can operate any of the load at a particular time. That flexibility you have into the system. Okay. So this is the flexible load. Flexible load. And next, if you can see, it's a load was initially like this and you are increasing the load. So this is a kind of load growth. Okay, so A is matches with the peak clipping, that is the A. B is the that valley filling, fifth of B. C is the load shifting, C. And D is the, if you can say, the conservation, D. Flexible load, E. And the load growth is F. Okay, so this is the question and solution of this question. Next question related to the some of the advantage of this DC systems over the AC. So DC kind of advantageous as compared to AC. So there is a one important that thing is that skin effect. Skin effect is absent in the case of DC, but it is present in the case of the AC. So there are four statements I have put it out. So just you have to let me know which statements are true, which is false related to this skin effect. Okay, let me give the solution for this question. This is related to the skin effect of skin effect in the AC systems. So first statement, if you can see, the skin effect refers to the tendency of the AC current to flow predominantly near the outer surface of the conductor. That is true. If you can see the right side image, what is there in the DC system? When the cross-sectional area of around the conductor available for conducting the DC current, so you can see that the current is uniformly flowing all the over all the side of the conductor. If you can see, not on the surface, not on the center region, it's a overall the flow of the this current is there. If you can see the lower frequency AC, low frequency is like 50 hertz, 60 hertz system is there. So in this system, the central pass, if you can see, there is a no current which is flowing. Current is flowing to the outer surfaces. Okay. So this is, but the area of the outer surfaces is high, where the region where the current is flowing. So if you go with the high frequency AC component, like 1 kilohertz, 10 kilohertz, like that. So in this scenario, if you can see, this is the overall reason where the current is not flowing. So current is flowing here only, at the most of the outer surfaces only. So this is the effect of the high frequency AC when the current is flowing through the cross sectional area of the same conductor in the high frequency AC system. Okay. So the first statement is a true. Okay. Second statement, what is telling that the skin effect become more prominent at a lower frequency, causing the increased resistance in the inner region of the conductor. That is false. Why? Because the high frequency, this skin effect is prominent, not on the lower frequency. Okay. So the second statement is false. Third statement is telling the skin effect has significant implication in the high frequency applications such as the radio frequency transmission, power distribution, microwave. That is true because it is the high frequency system is there in the radio frequency and this power distribution of at the microwave frequencies. Fourth statement is telling one way to mitigate the skin effect is by using the stranded conductor instead of the solid conductor, which increases the effective cross-sectional area. That is true. Okay. So this is the overall answer of this question. Next statement is related to the classification of the power converter in the AC microgrid. Okay. So here the certain topologies are given. This is the one topology, second topology, C is the different topology, D is the another topology. And the right side you have given the four options. That is whether it is a grid forming, grid feeding, grid supporting voltage source, grid supporting a current source. Okay, just match it out which from the left side is matches to the right side correctly. Okay, I'm giving you a few minutes to solve this question. Okay, let me give the solution for this question. If you can read it out the statement, what is there? This first is the, if you can see, this is the whether it's grid forming or the grid feeding mode. So first is actually the power converter into DC grid. So this question is actually a very simple question. Just I am leaving out for you to solve this question, because if you go at the statement that the which is the in which mode it will behave as a voltage source, in which mode it will behave as a current source, and while behaving in the as a voltage source, whether it is a grid supporting mode, grid supported voltage source or grid supported current source. Okay, if this also, if you can find out that I'm giving the C and D options correctly, that this is the grid supporting voltage source and this is the grid supporting current source. Okay, for the A and B statement, just you have to go through that, whether it is grid forming or the grid feeding. Okay, what references are needed when you are forming a grid, what references you need for the grid feeding systems. Okay, moving to the next question. This is a question related to the what are the motivation behind the DC power system. Okay, so just you have to read out the what kind of motivation is there behind the DC power system. Just let me know. Okay. Last 2 minutes to solve this question. Okay, let me give the solution for this question. If you read out the first statement, what is telling that decreasing the power convergence stated, that is true. Suppose you are using a DC bus, okay, and you have the DC generating sources. Suppose you have the wind as well, you have the solar as well. So these are the DC generating sources. You directly connect with this DC bus bar, okay. Wind also you are AC generating, but you convert to the DC, you can directly connect. Suppose you have this AC bus, okay. So solar is generating DC, no? So you need the DC to AC converter for connecting to the AC bus, okay? For the wind as well, you are converting first AC to DC because it's a variable, because the speed is variable, so there is a variable frequency. So AC to DC, then you convert to the AC for connecting. So if you can see the convergence stages between the when you are connecting with the DC, when you are connecting with the AC, actually it is lower in case of the DC. That is first statement is true. Second statement is the increasing the transmitted power by a cable. That is also true. If because the power capacity level of the DC power system is way higher as compared to the AC. Third statement, what is saying less protection issue. That is also true. You don't have any losses. You don't have any protection mechanism which is needed because the most of the things related to this frequency issues. Okay. In case of the reactive power also it is basically absent in case of that, okay, in between the DC system, okay. EG system integration because you don't need in a frequency synchronization system. Already DC system is not dependent upon the frequency. Less stability concern, that is also. So these are all the motivation for the using the DC power system as compared to the AC power system, okay. So this is a question I have put it related to this power losses for the on-state power losses for the conversion of this MOSFET. In this type of question, just you have to remember that this MOSFETs are actually represented as a single resistor. Okay, in case of the resistor. Okay, so in case of the on-state, in case of the on-state, okay, when it is in off state, that is actually a open circuit switch. Okay. So in the on state, it we have as a resistor. In the off state, it's actually a open circuited. Okay. So if you see the power on state power loss, it's actually I RMS square R because it's a resistor. So I RMS what it could be there? If you can see the figure itself, it's a 10. 10 is given. Okay. Root is the pi divided by 2 pi. Okay. Ka whole square multiplied by resistor. Okay. What it will come? It will come 100 divided by 1 by 2 minus 0.5. Okay. This is a 50. It will come out to be 7.5 watt. Okay. So the C option is correct. In this type of question, just you have to remember that this MOSFET is actually represented as a single resistor in the case of the on state. In case of the off state, it just behave as a open circuited switch. Okay. And if we ask the power on state power loss, just you have to do the IRMS square by R, that is a 10 root pi. Pi is the time duration for which the pulse is there, and the overall time duration, that is 2 pi. Okay. So what could be the IRMS? IRMS is 10 root pi by 2 pi. If somebody asks the what could be the average, I average, it's a 10 pi divided by 2 pi. Okay. So this is the question how you are going to solve it. Next question is related to the what kind of valid realization of the switch. Suppose this is the one question is given that this switch is a, suppose you are blocking the both kind of voltages. So it's a bipolar switch, and but the current is flowing in the one direction. It's a unidirectional. Okay. So it's a bipolar unidirectional switch. Unidirectional switch. Okay. So here the four topologies are given. Just you have to tell me that which topology is correctly matches with this topology, that is the bipolar unidirectional topology. Here the options are given 1, 1 and 2, 1 and 3, 3 and 4. I'm giving you 2 minutes to solve this question. That is not a very big question. It's a very easy kind of question. Okay. Okay, let me give the solution for this question. If you can see out the first switch topology which is given, it's actually a thyristor. Thyristor is a bipolar and unidirectional switch. So first statement is first switch is topology is correct. Second switch topology, if you can see, the current will flow from this here, and also it can flow from here through the diode. So it's a bidirectional switch. So the second statement is false. Third statement, if you can see, it's a plus minus. It can block and it's a negative positive. So it's a bipolar switch, and it's a unidirection because it can sweep, because this diode cannot allow the flow to the flow of current in the opposite direction. So third is also true. Fourth, if you can see, it's also a bidirectional switch. It's also not correct. So first and third option is correct. So how can you check whether it's a unidirectional? Just check the topology that which devices allow the current is which direction. Okay. So suppose this is diode, it will allow in one direction. Suppose if it is a thyristor, it's also allow in one direction. If it is a MOSFET if you can see, so it can have the inbuilt inherited body diode. It can allow in the two directions. Okay. So this is a correct statement. So if you can move out to the next question that is related to this VI characteristic. Okay, just I am leaving up to you. I will share the slide to solve this question. This is similar as compared to the previous. Okay, this is the one question I have put it related to the IGBT and MOSFET characteristic. Just let me know which statement is true. Okay, I'm giving you 1 minute to solve this question. Question is not big enough. Okay. Okay, let me give the solution for this question. What is the question is saying that? Let me see. Okay, let me explain this question. What is saying that the devices such as the IGBT, MOSFET, diode, and thyristors, which of the following is correct? They all are the majority carrier devices. There are two types of devices. One is the minority carrier devices, and other is the majority carrier devices. Okay, minority carrier devices having the this minority carriers during the switching off period. So they this is creates a longer duration of the off time as compared to the on time. So T off becomes higher, okay, than the T on time. So if you see the frequency, it's a 1 upon T off plus T on. So if the T off is higher, it means the frequency will lower. Okay. So but if you see the higher frequency devices, which are like the MOSFETs and IGBT, they are the majority carrier devices. They have the lower off period times. Okay. So this is false. Second statement telling R4 devices minority, that is also false. IGBT MOSFET are majority carry devices, where that is true. MOSFET is that is false. Okay. And the next statement, this is related to buck converter only. Just step down chopper. Thus you have to let me know which statement is true related to the average DC voltage across the freewheeling time. Okay, let me give the solution for this question. So here I have already told in the previous slide, you have to use the law of conservation energy into that. So that is actually the P multiplied by T is summation of the P by T is always actually equal to the 0. Okay, here also you have to use the voltage balance, because I'm considering that the current is constant. So voltage balance is one of the criteria. Suppose what is saying, if you can see here, it is a step down chopper which operates at a DC voltage and feeds a DC motor armature. Okay, with a back EMF of EB. The buck topology looks similar to like this. This is like this. Suppose this is the switch one, this is the diode, and this is the inductor which is connected to motor who having the back EMF as EB, and this is the VDC. Okay. So the DC voltage source feeds a DC motor armature with a back EMF EB. From a oscilloscope test, it is found that the current increases for the time of the TR. This is a TR time where the current increases. Then it falls to the zero over a time of TF. Okay. then it remains 0 for the time period of the T0. Then in every chopping cycle, the average DC voltage they have walks across the freewheeling diode. Okay. So if you can see the freewheeling diode, in this scenario, first will the this switch will be on, the DC voltage will be off. So the all the voltage which is occurring across this freewheeling diode is actually the VDC only. Okay, so VS, you can say VS. So if the freewheeling diode is being on, in that scenario, the voltage will be zero across the freewheeling diode. So like this, it will be there. So let me take the another color for that. So this will be 1 and this will be 0. So after the freewheeling diode is off, all the voltage which is occurring, because this is also off, this is also off. In this scenario, the all voltage actually occur across this cycle is actually the EB. EB voltage will occur during the time period of the T0. Okay. So same cycle will be followed further. So if you wanted to find out what would be the average voltage, Vs multiplied by Tr plus 0 multiplied by Tf plus Eb multiplied by T0 is equal to 0. Okay. What is will the average voltage? Average voltage we wanted to find. Just you don't have to zero it. Just you have to take the Tr plus Tf plus T0. So the Eb multiplied by T0, that is this option is correct. Vs multiplied by Tr, this is already 0, this is Eb and this. Okay. So this is the correct for this statement. So I'm moving to the some of the power flow related to statement related to the power flow in the electrical system. Just you have to let me know which statements are true. Here I have given the 5 statements. Just let me know which statements are true and which statements are false. Okay, let me give the solution for this question. What is it's telling that we can see that these statements are related to the active power and the reactive power transformations here in this system. Let me read out the first statement. What is telling that? It is saying that the active power flows from the source side, source from the leading voltage to the source of the lagging voltage. That is actually true, because if you can see the higher power angle, suppose the delta 2 is higher, V1, V2 angle delta 2, V1 angle delta 1 is there. So a higher this, if the inductive component is more in case of the transmission line, that is always true. So in this situation, the power flows from the leading angle. Suppose the delta 2 is greater than delta 1, leading angle to the lagging angle. Okay, lagging angle. And reactive power, if you can see, it will move from the higher voltage side to the lower voltage. Suppose the V2 is greater than V1, so the reactive power will flow from the higher voltage to the lower voltage side, lower voltage side. Okay. So the reactive power flows from the region of the higher voltage magnitude to the region of lower magnitude. That is true. Reactive power is responsible for the transmission of usable energy in power system. That is false. Reactive power is not a kind of utility, because if you can see, the S is actually the root P square plus Q square. If you are having the higher reactive power component, the P will always drop down. Okay. So this is not a utilized part. So fourth statement, if we can say, the active power flow is directly proportional to the cosine of the phase angle between the phase differential between the voltages. No, that is the sine of this. Okay, active power flow is the cosine, cos of angle. No, it is the sine of angle delta 2 minus delta 1. Okay, fifth statement, if we can see, the increase of voltage difference between the 2 points is always to increase, results in increase the flow of the reactive power. That is false. Not voltage magnitude, the angle. Okay, 2 point always results in a, not always, not always. So here this statement is actually false. So fourth statement is actually false. So this question is related to the higher voltage transmission lines. Just you have to tell me that which impedance is primarily dominated by which the components due to significant magnitude compared to the other. Okay. Just let me know which statement is true. Okay, let me give the solution for this. The inductive components are always greater than the capacitive component. in case of the in case of the in case of the this significant in the high voltage transmission line. Okay, so this is next statement. This is same what is the graphical representation of the power loss. So if you can read out the statement, what is telling the power loss in the MOSFET is directly proportional to the square of current. That is true, because I have told in the on state the losses which you calculate is actually the IRMS square multiplied by R. So it's a square of the current. If the current through the volt magnitude double, the power loss will also double. That is false. If it is double, it will become 4 times. The on-state RDS of the MOSFET is the primary factor in determining the power loss in the resistive model. That is true. Lower RDS result in the higher power loss. That is false, because it's a directly proportional. For a given current, increase in the on-state resistor will increase the power loss. That is true. Okay. So this is the correct statement for this. So moving to the next part. Next part is related to this one of the duty cycle, finding of the duty cycle. It's a basic question. Uh, Let me give you 1 minute to solve this question. After that, I will clear out this doubt. Okay. Okay, let me give the solution for this question. Uh, if you can see the what is the they are asking about the duty cycle of the buck converter. The thing is that the voltage is looking like that. Okay, it's a 30 volt during the on state and minus 20 volt during the off state. Okay, and overall time period is the TS. Okay. So here you just have to use the power balance equation, that 30 multiplied by, it's a T on, no? T on is the dt plus minus 20 multiplied by 1 minus d times of t is equal to 0. So 30d is equal to minus is equal to 20 minus 20d. Okay. 50d is equal to 20. So d will come out to be 2 by 5. It's a zero point 0.4. So duty cycle will come out to be 0.4. Okay. So this is a one question related to the speed control of wind turbines. So here the one there are three threshold speed. These three threshold speeds are there. A, B, C. Just you have to tell me that which speed is actually being depicted by these uh, nomenclature of A, B, and C. Okay. 1 minute to solve this question. let me give the solution for this question. If you can see the solution here, the first is the cut-in speed. Cut-in speed, the below which the turbine will not produce the power. Second is the rated power at which the rated power of the turbine is produced. And last is the cutoff speed beyond which the turbine is not allowed to achieve power. So this is the what is the nomenclature A, B, C. So here if you can see, this is the A, this is the B, this is the C. Okay. So this is a question related to the capacity ramp rate. That's the I'm not giving the few minutes to solve this question. Just I will read out the statements which are correct. So ramping is the process of adjusting the power output of the electricity generation to match the changes in the electricity demand. It can be gradual and occur on the various time scales such as the minutes to the hours. And the true is the rapid and larger ramping events can affect the stability of the power grid, leading to the challenges the maintaining in the balance between the supply and the demand. Next, related to the capacity firming. Firming is also one of the concept. So it is the process of ensuring a reliable and steady power supply by addressing the intermittency and the variability of the renewable energy sources. It also provides the strategies to make the renewable capacity more dependable rather than increasing its maximum potential output. Okay. And also, this is a question related to the RE sources, which is creating a challenges to maintain the stability grid. Here, the five statements are there. Just let me know which statements are true. I'm giving you few minutes, 2 minutes to solve this question. Okay. Okay, let me give the solution for this question. It is also not much complicated, but it seems complicated just. So this question is related to this RE sources which created challenges into the systems. So first statement, if you can read out that most renewable energy sources generate a stable that AC output, that is also false. Second statement, the presence of the RE sources with a variable output poses a challenging maintaining the stability of a grid. That is true. So suitable architecture is necessary to manage the power flow between the different micro sources in the grid. That is true. Next statement, if you can see, the RE sources typically generate DC output, variable frequency or the variable voltage output. That is true. So the integrating next statement is the integrating RE energy source into the grid requires no special consideration or adoption. That is false. Okay. So these are the correct statement for this question. And the next question is related to the watch condition must be made for a microgrid to operate autonomously and why it is important to employ power control. Okay. So I'm reading out the statement what is telling the microgrid must have a constant power supply in the load demand. That is true. Voltage and frequency stabilization condition must be met. That is true. The microgrid must be also connected to the main grid. That is also true. Microgrid must only use renewable energy sources. That is false. Microgrid must always connected. That is also false. Voltage and frequency stabilization condition must be met. That is true. Must have the constant power and the load demand. That is false. It don't have need to be constant power and the constant load. This is the one question related to the power absorbed by the resistor. You have to find out like this. So in this questions, just you have to use some of the techniques. Suppose this is the parallel system is there. Just you have to 12 multiplied by A divided by 20. It will come out to be 10, 6 at 6. It's a 4.8. So this is the overall 4.8. If you can add with this 1.2, it will come out to be 6. So this 6 and this 3 and 6 are in parallel. 3 multiplied by 6 and 9. 3 3 and 9, 3 2 is 6. So this will also come out to be 6. So 6 6 parallel, it come out to be 3. So overall system will become like this: 20 amps, and this is the 2 ohm, this is the 1 ohm, and this is the 3 ohm. Okay. So just you have to use the current one. So current which is flowing in this side, so this will be 2 divided by 4. It will come out to be 10 amps. Okay, so 10 amp current will be flow here. So the power absorbed by the resistor will be 10 square multiplied by 1. It will come out to be 100 watts. Okay. So in the next question, if you can see the current, you have to find out the what would be the value of the I1. In this, you have to just use the voltage KVL here. So minus 2, which is coming into the system, plus V minus 20 divided by 2 plus V minus 0. This is suppose I am considered grounded, divided by 5. So multiplied by 10, it will come out to be 20, and it will come out to be 5 minus 5 multiplied by 100 plus 2V is equal to 0. 7V is equal to 120. I think so. Minus 2 plus V minus 20. Sorry, this will be 5. This will be 5. So this is wrong. So it will come out to be minus 10 plus V minus 20 plus V is equal to 0. 2V is equal to 30. V is equal to 15 volt. So the current which is flowing through the I1, it will be equal to 20 minus 15 divided by 5. It will come out to be 1 amps. Okay, 1 amps is the correct answer for this. So hoping for this next question, if you can see the current which is flowing through the 5 Henry inductor, energy observed for the 40 is equal to 5. So this is the t greater than 0, this is the t greater than 0, t greater than 0, it will be 30 t square, it will be like this, and it's a 0 for the t less than 0. So for the energy absorbed for the at is equal to 5 seconds, just you have to find out that something. So this is actually the inductor, okay, half L I square. If you wanted to find out the what could be energy stored in that, just half L I final T2 square minus I T1 square you can do. Half multiplied by 5, high T2 square is actually equal to VT, it's a VT now. Okay, so voltage is equal to L di by dt. So I is equal to 1 upon L V dt. Okay, so just you have to use that information, that I you have to find out from that. Then you have to just use this half L I square at a 5 second minus half L I square at a t is equal to 0 second. So you can find out the what could be the energy absorbed by that inductor in that whole overall time span. This question is related to the droop control. This also I have put a solution also here. Just you have to go through into that. Okay. So this question related to the DC microgrid typical architecture. here also I have given the solution for this question. This question is also related to the same, and this is related to the master and the slave configuration that you have already we have discussed. Suppose the question, if you can see, which of the following master controller allow the microgrid to operate in the islanded mode for an extended period due to the ability to regulate voltage and frequency? This is the ESS integrated with the DCs. Okay. So these are the some of the question related to the peer-to-peer control, group control, and other functions as well. So uh, this is the one question related to the microgrid. This is similar to the what we have discussed in the first and second question. Okay. Here the one question I have written related to the primary purpose of the management system. There four statements are related given. Just tell me that which statement is true. I'm giving 1 minute to solve this question. Okay, let me give the solution for this question. This question related to the energy management inside of this microgrid. So if you can read out the first statement, what is telling that to only the monitor the RE generating sources. No, you have to supervise control in the plan. That is P option is correct. To eliminate the need, that is false. To prevent the use of distributed energy in the microgrid, that is false. Okay, so these are the similar question later. What is function of the energy management system? You already know that it needed to be managed from the all the sources which is generating in the storage system, and also if it is connected to grid, what amount of current and the energy will have to be taken from the grid. Okay, to manage the net energy balance. Here the one question related to frequency and voltage. Here just you have to know that frequency is strongly coupled. For the frequency operation, it is strongly coupled with the reactive power. Voltage control through the increasing the frequency control by increasing and decreasing mechanical power. So frequency is PA. Okay, you can maintain that frequency, and if you wanted to control the voltage, you have to inject the reactive power. Okay, these are two things you have to remember into that. Coming to the next question, it's related to voltage control. Same. You have to just make sure that if it is a AC system, uh, if it is a AC system, you have to inject the power, inject the power based upon that. And if it is a voltage control system, that voltage DC system is there, so voltage controlled by injected power into the DC system, and summation of the converter's power will be always must be equal to 0. Okay. Next question is related to the master and slave topologies. This I have already explained in the second tutorial session. Just go through that. These are also been explained. Active power loop, vector control, this are already been explained. Okay. This is one question related to what is the primary function of the DC link capacitor in the VSCs. Okay. So here the most important thing is that to limit the DC voltage variation caused by, because you have to maintain the delta V as a constant. So no, you have to maintain the voltage as a constant. So the extra reactive power, which is voltage difference, which of fluctuation could be there, that need to be absorbed or give the power supply during through the DC link capacitors. Okay. So one question related to the control of the DC microgrid, that which of the terminal is responsible for balancing the power flow between the grid, that is a slack terminal actually. Okay. So next statement is what is the one key advantage of the central control topology in the defender microgrid, that disadvantage you have to tell. This is actually the dependence upon the central controller. Central controller is the one of the hierarchy that if the central controller is being failed to operate, so all overall potential system will collapse. Okay. This is one question related to the which control strategy in a DC microgrid allows the plug and play operation without needing the additional communication channel. That is the autonomous control. It automatically control and detect the systems. Okay. Uh, One question related to the this major advantage around the Westinghouse AC power system prevailing during the Edison DC system during the war of content. That is C option is correct. That is the AC could transmit power at a higher voltages with the fewer losses. Okay. So this is a one of the question related to DC market. One of the question related to here the energy savings can be achieved. So if you're converting from the AC system to the DC system, what could be the potential energy saving you can achieve? It is actually related to the one of the this 15% energy you can save from that. Which of the following is the key benefit of using the DC system with a modern household? That it is a higher efficiencies connecting the modern energy sources like PV panels and the batteries. And what does the large signal stability in the microgrid refers to? It's the ability to withstand largest disturbances like fall, settle to a new operating point. Okay. What happens to the microgrid when it is operated in the islanded mode? Actually, when it is already operating in the islanded mode, it is disconnected from the main grid due to fault or unplanned operation. Okay. Which is which of the following is classified as the power electronic converter interface DCUs? It's actually the PV based systems, which already know we know that transient stability, steady state stability that I will explain. I have already explained. There is one question related: what is the main cause of instability in the DC microgrid? Actually, if you see the power electronic interfaces, power electronic devices which are being used, it's actually a constant power devices. It's a CPLs. In this scenario, what happens that if your power is constant, suppose your voltage dip at a DC terminal, the current will increase, and if your voltage will increase at DC terminal, the current will drop down. Okay, it means that it's having the inverse relation between the V and I. So power is equal to VI. That kind of power is constant, means that a V is inversely proportional to the current, or current is inversely proportional to the voltage. In this sense, okay. So this is a question related to that CPL only, that is a cause of a disadvantage or major related to differences between the impedance mismatching between the system. Okay. This is one question later, what percent of load is composed of the constant power load? That's actually the 80-25%. Okay. If you go with the next question, what is there? What is behavior of a constant power? It's behave as a negative resistance in parallel with the constant current. Okay. Coming to this next question, that purpose of the boost converter in the system, it is stabilizing the maintaining the DC bus voltage. Okay. Oh, this is the small question which is related to this key factors ensuring that filter components and the frequency and voltage control. And this is regarding the power balance and all. This is a master and slave configuration. This is related to the droop control. These are topic you have to prepare for that. This is a related question with the outer active power loop control in the VSCs, and this is the Q axis control in the vector control. So this is one of the question can be found out related to the DC link capacitor in the VSCs. What is the major functionality of that, and which buses is responsible for maintaining the excess power demand into the system? Uh, this is the repeated question, I think. Was thing house. This is not power system, and this is a repeated question. This is repeated question. CPLs are the important concept which you have to see. Maybe one question can come. This is one question related to damping. Damping related to which methods use a resistor, capacitor, inductor. There are two types of damping methods are there. One is the active damping. Second is the passive damping. Okay. So this passive damping method actually uses this passive stabilization method. That is passive damping is uses this resistor, capacitor, inductor to improve the system stability. Which stability analysis is commonly used for PDCs? That is actually the impedance and admittances methods. Okay. A sliding mode control is having this primarily used for the ensuring the robust control in the presence of the uncertainties. That is one of the important feature. So here if you can see also the answer written that to ensure the robust control in the presence of system uncertainties. And sliding mode control is a robust non-linear technique which is used for the system with uncertainties, making it suitable for the applications like DC-DC converters. Okay. So this is the few questions which I have put into the slides for the final preparation, final revision of this overall course. So if you are having any doubt, just let me know. And we are having few minutes to hear extra. Otherwise, I will end the session for today. Okay. Just you have to go through the slides which I have put it, questions which I have put it, and also the assignment question which is important, and the lecture slides which are there on the NPTEL websites. You can watch the lectures as well, but at the last moment, this notes can be useful for you. Okay. So that's all.